Okay, today we are going to talk about IPs and Internet Protocol and networking a little bit and converting from binary or base 2 to decimal or base 10. Okay, let's start off with TCP/IP. And when we think about TCP/IP, there's 4 parts that we kind of need. So if you've got a computer and you want to get to the internet, most people kind of have an idea about this. They need the IP address, the subnet mask. Not always necessary, but helpful to have is a DNS or a domain name system, domain name server, and finally the default gateway. Okay, and the numbers are usually something like, you might see something like 192.2.168.1.55 with a subnet mask of 255.255.255.0, DNS 8.8.8.8, and then a default gateway of 192.168.1.1. Okay, you may or may not have seen something like this. If you, we will get into it in class where you're gonna have to go into the properties of the Ethernet adapter for a device and set these up. Now, all the devices on the internet or that want to communicate to each other, network together, have to have an address. And if you haven't assigned one, it probably means that it's dynamic or DHCP assigned. So DHCP is a server that sends out all this information to any device that connects to its network. So we don't have to go in and manually do this, even though we need to know how, for a few reasons. To get started is, what if we've got a server that we're working with and it's set up on DHCP? So we get an address. It gives us like 192.168.1.300, 200. And then the next day we get 202, and then maybe another one, 195. And we try to connect to it remotely to this address, but it's changed. So we have to be thinking about that. That's one of the reasons we statically, permanently assign an IP address. Okay, so we need to talk about IP addresses and why does it look like this? What does all this mean? Okay, let me start a new page. Okay, so when we look at an IP address, we've got a number with a period, a number with a period, a number with a period, and a number. Okay, we call this the dotted decimal notation. And notice that there's 4 numbers separated by 3 comma or periods. Okay, let's see, where do we want to go with this? Something to think about, something to know. An IP address, each one of these little sections here is called an octet. And there's 8 possible spaces or placeholders for these. So we might write this out as 101011 1 2 3 4 5 6 0 0 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8, and then 0 0 0 6 7 8. Okay, so that's an IP address, and we can convert this to binary, and I'm going to show you how to do that in a little bit. So this equals a number, a decimal number that we would recognize, you know, separated by the periods. A couple things to notice here. There's 8 positions here, so this is called the octet, and there's 4 of them. So 8 times 4 is 32. So we have a possible, you know, there's a third. This is an IP address is a 32-bit number. Okay. Let's start off with some basic information now. And this is just something we have to memorize. You're going to see it enough eventually to where you're going to know it, but you really should know this because it's important when it comes to computers in general, the different classes. We'll talk about classless IPs in our Cisco classes, but for now we're just going to talk about the basics, classful IP address classes. Okay, so we start off with a class A. There's a B and a C. There's also a D and an E, but we don't spend a whole lot of time or mess with those. These are reserved for multicast, and these are experimental, so we're not even going to be, dealing with them. We have an A, a B, and a C, and these numbers are a different range. This is just unfortunately something we have to memorize. So class A is from 1 to 127. Class B is 128 to 223. Whoops. Class C, I'm sorry, I messed that up. That's a class B to, erase that, to 191. Okay. 191. Class C is 192 to 223. What I said before, 223. Now, if you've played with IP addresses at all, or done any networking, you might recognize a couple numbers. You might have recognized 127.0.0.1. That's the loopback address. That's a special address, and we all have a bunch of special addresses that we'll talk about here. But if you can remember the loopback address, and then that number I threw out on the slide before, 192.168. number. That's pretty common when we're dealing with personal LANs and WANs. It's a common number. And if you can remember the 127 and the 192, that can help you remember the different classes. If it's less than 127, the loopback address, it's an A. And if it's higher than 192, it's a C. Anything in between is a B. Okay? Yeah, so the reason, let's see. Okay, the next thing we need to know, we're going to talk about why in just a little bit here, is each class of address has a subnet mask that goes along with it. Okay, and the previous slide, and this is probably pretty common if you've played with any of your IPing it with your home, Soho, anything like that. It's 192. I'm sorry, we're talking about subnet mask here. It's 255.255.255.0. A class B subnet is 255.255.0.0, and then the class A subnet mask default is 255.0.0.0. Now you may see a pattern here. We've got this 255, then 255, 255, then 255, 255, 255, and then notice here we've got 0, 0, 0, 0, 0, and 0. They're reciprocal of each other. So this is important here. This subnet mask tells us how many networks we have and how many hosts we have. Let's go to a new slide, a new page. Okay, so again with our class A, class B, and class C, the subnet mask is 255.255.255.0, except that's wrong. That was the class C subnet mask. .0.0.0, 255.255.0.0, 255.255.0. Okay. Now I'd mentioned on the previous slide here, this first number, or when you see a 255, is the network, the number of networks we have in a class A. So notice in a class A, we don't have very many. We go from 0 to 255. Well, we don't use okay, let's explain where that number comes from. I've mentioned that each one of these is 8 bits, right? 8.8.8. Well, that's actually Google's DNS, but there's 8 positions here. So 2 to the 8th, 8th position, dot 2 to the 8th position dot 2 to the 8th position, 2 to the 8th dot 2 to the 8th dot 2 to the 8th. Okay, so 2 to the 8th, if you do the math, equals 256. We have some special numbers. We'll talk more about that in a minute. But when we're dealing with IP addresses, we don't use 0 or 256. Those are used for something. They mean something. It's the network number, and this is the broadcast. So we have numbers between 1 and 255, giving us a possible number of 254 addresses, usable addresses. Okay, that's where we're getting these numbers from. Why does it go? Why do we stop at 255? That's just as high as it goes, and we'll see that when we're converting decimal to binary in just a few minutes here. Okay, so that's where the 255 comes from, and so anywhere, yeah, okay. So this, when we're looking at our subnet masks, the numbers that have a 255 in it tell us what are the network numbers, okay? So in a class A, we have a possible 255 addresses, different networks. So let's say I had a school, okay? And I've got in LA, I've got a campus. I've got a campus in New York, maybe in Miami. And then maybe there's 30 or 40 campuses elsewhere. We could use we could use any class we want to set this up. But if we use the class A address, we have a possible of 255 different networks, different locations we might use, and a possibility of this many hosts. So we get a lot of hosts with not so many networks. With a class B, we have 255, 255. I'll explain that in a second. We have this many networks, and we have this many hosts. And then in the class C, we have a whole bunch of different networks and not a lot of hosts. And this is a problem, or all of it is. We actually ran out of IP addresses, IP version 4 addresses a few years ago. IP version 6 is out, and we won't run out of those. But let's do a little math here. And break out my calculator. I don't think I could show it, well, because I'm sharing just the screen. But if we do, let me get back over here. So remember, this is 8 bits. So 8.8.8.8. So 2 to the 8th. 2 to the 8th is what we said a second ago. 2 to the 8th is 256. It's not a very good equal sign. 256. So in this case, we've got this many networks and 2 to the 8th possible hosts, possible different machines on our network that we can use. In this case, we've got 8 bits here and 8 bits here, so that's 16. So we have 2 to the 16th. Break out your calculator and do that. 2 to the 16th power. And that comes up to 65,536. That's how many possible, in this instance, if we're using a subnet class B, we have a possible 65,000 different hosts to use. That's a lot of computers. If we do the top one, 2 to the 24th, 8 and 8 and 8. 8 times 3 is 24. 2 to the 24th equals 16,770,216 possible addresses. So in this scenario, we only have a possible 255 different locations, different networks. They could be at the same location. I'm just using that as a reference, or just kind of something to grasp. But we have a possible of 16 million addresses at each location. So that might be a good reason to use a class A. A class B, we could have 65,000 different networks, locations, and 65,000 different IP addresses. Here we've got a whole bunch of networks. So that's why a lot of businesses, a lot of small, mom and pop shops that only need about 256 addresses were buying up these Class Cs because there were so many of them available. You can imagine, of all the businesses in the world, everybody probably wanted a Class A address because they have all these different hosts to use. Well, a lot of the ISP or internet service providers would get a Class A address and split them up. You'll learn how to do that later. But then you could have like one Class A address, and then they could have, a whole lot of customers to give out all these addresses to. So all that, and one more thing too. So I mentioned that a class, or the IP version 4, is a 32-bit number. So if we take 2 to the 32, well, we're only capable of using the different number of hosts here, but you can see there's a finite number of addresses here, and we ran out. So one of the things that we've done, or one of the reasons we've done this, or we haven't suffered so bad, is because we've come up with alternate ways of dealing with the shortage. And that's why we're still using IP version 4, not so much IP version 6, even though most of our equipment now is capable, including our operating systems, of doing IP version 6. But what we're doing now is we're NATing. We're using something called a network address translation, where each host out on the internet, and this, I'll just use my example here, might have a single address, and it might be I haven't got that far yet. Let me come to it in the next slide. So let me start off again. New, save. Okay. Let's go back to our Class A, Class B, and Class C. Class A runs from 1 to 127. Keep getting ahead of myself here. 128 through 191. 192 through 223. And our subnet masks is 255.0.0.0, 255.0.255. and then 255.255.255.0. Okay. There's something else I want to show you here. But importantly, I want you to be able to recognize when I say a Class A, you've memorized this section here. And now we've memorized this section here, okay? So on a Class A, the network number is 255, and the possible hosts are 000, okay? On the Class B, the subnet mask is 255, 255, and then we have this many hosts. And then Class C, 255, 255, 255 with this many hosts, okay? So with that, we're going to start converting numbers, and we'll talk more about IP and how it ran out and all that stuff later when we're talking about networking, okay? So to convert binary to decimal. So a decimal number is a number that goes to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice that like an odometer on your car, when we hit that 0, we kicked in another place. So this would run 11, 12, up to 99, and we're running out of spaces again, so we add another one, 100. Well, in base 2, we do the same thing, but we only have 2 digits, a 0 and a 1. So when we get to 0, the next number is 1. Then we kick over again and we have 10, just like this. 9, next number is we add a place to it. So the next number is 1, 1. And then we're out of places again. And then we do 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, and we're out of places again. So we pop that in and so forth. Okay, so that's base 2 and this is base 10. So what we want to do is to be able to convert between the two, because the computer doesn't speak decimal, the computer speaks binary. So we need to understand what these numbers mean and how to use them and everything like that. So we're going to be converting our numbers, natural numbers, to base 2. So let's take an example, but we need a tool to do this first, okay? So if you can remember doubling numbers up to 16 positions, because remember our IP address was a number, 8 positions, 1, 2, 3, 4, 5, 6, 7, 8, with a period. Come on. And so each one of these has a position and it's a number doubled. So let's just to start off, and you know, it'll make sense later, hopefully. We have 1, 2, 4, 8, 16, 32, 64, 128. So we have 8 positions. 1, 2, 3, 4, 5, 6, 7, 8. How that works is simply 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. So if you do the math, it comes out that way. But we're just going to keep it real simple. 1, 2, 4, 8, 16, 32, 64, 128. If you can remember that, you can convert binary to decimal. I drew that line in there just for my readability. I get my numbers cross dyslexia and everything like that. So let's take a number, okay, and let's make it, remember the binaries are just ones and zeros. So we'll have a 1, and I'm just kind of making this up, 1, 0, 0, 1, 0, 0, 1, 0. Okay, that's a binary number, and it's got 8 places. It's an 8-bit number. So what we're going to do is convert this to decimal. So the simplest way to do it is just kind of, you know, looking at the places. If the bit is set, if it's turned on, if we got a 1 here, we count it. So let's do that. Let's take a look at this, for example. So in the 128 place, do we have a number? Do we have a 1? Yes, we do. So let's remember that, 128. Okay. Do we have any 64s? No, we don't. So let's ignore it. A 32? No, we don't have one, but we do have a 16. So let's do that, and let's add it together. 14, 4, 144. So far, we're not done. Do we have any 8s? No. Do we have any 4s? No. We do have a 2. And we'll add 2. 146. Do we have any zeros? No. So we're done. So 1001, 0010 equals 146 in binary. Not too bad, right? Let's take a look at another number. Let's do 0011, 1011. Okay, we're going to figure that out. And you just got to do basic addition, subtraction to do this. So any 128s? No. How about a 64? No. A 32? Yes. 16? Yes. An 8? Yes. No 4s. A 2? Yes. And a 1. Add those up. 6, 7, 8, 9, 10, 18, 19, 3, 4, 5, 59. So 00111, 011 equals 59. Okay? Any number I throw at you should be able to do it. Ah, interesting. Let's do this number. 1111, 1111. So we add 128, 64, 32, 16, 8, 4, 2, and 1. And guess what that might come up to? 255. That's why that number would go as high as we do there. If we were to go to 256, we ran out of places. We would add another decimal here. 128, 256. So it would be 100000000. Okay, so that's where that number comes in. And then on the flip side, 00000000 equals 0. There's nothing. If we had all this, but we put a 1 right here, then our number would be 1. Okay? Not too bad. Let's go the other direction. We went from decimal to binary. Let's go from binary to decimal. I'm sorry, the other way around. New. I shouldn't multitask. Don't save. Okay, so let's use our handy-dandy numbering scheme. 1, 2, 4, 8, 16, 32, 64, 128. Okay, so we've got a number. Let's make a number 111. 111. Okay, so we'll start off with, does 111 go into 128? Are there any, let me see how I can explain this. Does 128, I don't want to say divide, go into, but are there any 128s in 111? Let's just run with this and I'll show you a couple examples. No, there's not, so we put a 0 there. Can 64 go into 111? Ah, yes, it's smaller, so it can. It always has to be smaller. So we do this, then we subtract 64. And that equals, hang on, my pen, 47. Okay, does 32 go into 47? Yes, it does. 32, subtract that out. We have to, unlike going the other direction, we can wait to the end to add it. We need to subtract it out as we do it. So in this case, we've got 515. Okay, does 16 go into 15? Is it what am I saying? Is it smaller than that number? No, it's not. So we put a 0 there. Does 8 go into 15? Yes, it does. So we bring it down here, and that gives us 7. 4 goes into 7, so we put a 1 here. Gives us 3. Does 2 go into 3? One time, yes. And then 1 goes into 1 one time. Leaves us nothing left over. So 111 going to that direction is 1111. Excuse me, 011 01111. Easy, easy peasy. Let's do another one. Okay, let's try 255. We know what that is, but let's just see if it works out, okay? So we'll start with 255. Does 128 go into 255? Yes, it does. Okay. It goes one time. 255 minus 128 is 127. Does 64 go into 127? Yes, it does. 3, 6, 63 times. Does 32 go into 63? Yes, it does. 32 gives us 15. Wait a second, did I do that wrong? No, wait a minute. Yes, does 15, there's a 15 and a 16? No, wait a minute, what the heck did I do wrong? Hang on a second. I was trying to do that in my head. Let me, 63 minus 32, 31. Yes, not 15, all right. Trying to get too smart on you guys. Hopefully you guys caught that. That's just way too big of a number. So that's 31. Whoops. 31. Does 16 go into 31? Yes. There's a pattern here. So look, 127 is 1 less than the number that I'm taking it away from. So 63 is 1 less than that number. 31 is 1 less than that number. 16 is 1. So this one should be 15. Okay. Does 8 go into 15? Let me start it back up over here. Yes, it does. One time. Leaves us 7. Does 4 go into 7? Yes, it does. With 3 left over. Does 2 go into 3? Yes, with 1 left over. Does 1 go into 1? Yes, with nothing left over. Okay, so that was 255. So either direction, as long as we can remember 1, 2, 4, 8, 16, 32, 64, 128, we can convert from decimal to binary. We'll go more into it later, why we're doing it. It gets a lot more complicated, so appreciate this. Remember our classes and the subnet mask that goes along with them. and that's gonna help us pick ranges and numbers and things like that. Okay, so the 4 parts of the making our computer work is the IP address, the subnet mask, the default gateway, and the DNS. Okay. We don't always need all of these, but it's something we need to be thinking about, okay? So when someone says, oh, let's connect our computer to the network, you should see these 4 things. If you didn't put them in, you have something assigned to you from a DHCP server, okay? If you want to see what that is, go to your command prompt and do an IP config if you're running Windows, IF config if you're running Linux. That'll tell you some of it. If you do an IP config all, that'll list everything for you, including the DNS and DHCP servers. Okay? Any questions? Text me or email me or talk to me tomorrow in class when we have a lesson. And we're going to use this to work a workbook that's part of your lab. And we'll do that later on in the week, okay? Girls. All right.